Can anyone please confirm me if you are able to see the screen?
Yes, sir.
Yes, sir. Yes, sir.
That's great. That's great.
Yes, sir. Yes, sir.
Oh yeah. So because this is a Google Meet, I cannot see the charts. Like if you are posting some questions, I cannot see your questions here. So my recommendation is that you can raise your hand, or you can like unmute your mic and you can speak whenever you have some questions. I welcome that. And otherwise, at the end of the session, we will definitely take some questions from all the participants. Okay, so let me start the session. So the talk is all about the cloud computing basics, and we'll try to understand the architecture of that what do you call, like, cloud, and we'll also see quickly what are the recent trends we have. So, yeah, as Professor Ayesha Bhanu introduced, I am the cloud ambassador for AWS Educate, and I'm happy that I am a bit aware of AWS concepts. And I taught cloud computing course for almost like 5 to 6 years. And I've been adjunct faculty to IIT Bhubaneswar for teaching cloud computing course to their students. So I visit their institute, Indian Institute of Technology Bhubaneswar, for teaching cloud computing course. So that's a basic idea of what cloud is, what I am, and the talk is all about. I'm sorry, madam. What is the time limit I have? Like, at what time I should stop?
Sir, at 11 o'clock, we all have to join the central inauguration, sir.
Oh, only I have near 45 minutes.
Yeah, 45 to 50 minutes, sir.
Okay. Okay. Okay, I'll try to make it possible. I came with a lot of content, but I'll try to minimize. Right. So first, we'll spend a couple of minutes on introduction, why, what, how kind of things for cloud computing, and we will also try to highlight what are the research aspects that you can focus on, and later we will highlight what are the research recent trends we have in the cloud computing that you can think of, and you can start exploring towards this. Okay, so why cloud computing? You can see here in this picture, there are days where we used to have application-oriented programs, or you can say application-oriented paradigm. At that time, like we used to have we used to use clusters, supercomputers for executing complex applications, or very computationally intensive applications. And over the period of time, this dedicated systems have gone up, and people started sharing the systems among others. Like there is a community of people who are working on a specific problem statement. Let's say a scientific application. Let's take weather monitoring, or let's take some atomic structure calculation, some sort of application. So the people use it to collaborate together, and they use to solve that particular application. Okay, and typically there were some time where the systems were shared in such a way that someone who is sitting in US and someone who is sitting in India, they share the systems in such a way that, like, the person who is in US uses the computer during his time, daytime, both the systems, the Indian system and US system, and Indian fellow uses the same system, that means I'm having only one system in the beginning. US fellow is having one system, but when I share both the systems, I can use two systems during my daytime, and during night time I sleep, and my friend uses again two systems during his daytime where I'm sleeping. Okay, so that sharing can happen, and this can be expanded across the globe to hundreds, thousands, millions of systems to run a particular application. So that was a collaboration kind of environment where if a single specific problem is considered to execute and see the results in a faster way. So the kind of parallelism is achieved, and by using multiple systems situated across the globe. And that paradigm slowly turned up into a new kind of computing paradigm called grid computing. And the goal of all these computing paradigms is to focus on the web scale problems. Okay, the idea is to scaling the applications. The more number of systems you have, right, the quicker the application executes. So that's our ideology at that time. And of course, because these are not like single system based, so they are typically they may be having homogeneous architectures or heterogeneous architectures, but typically they are distributed in nature. But over the period of time, we have come to a scenario where the paradigm completely changed, and now the paradigm shifted to what is called the service-oriented architecture. So this service-oriented architecture is very, very important, and it changed the way with which we live. Oh no. Oh no. Okay. Okay. The ideology here is that again the same infrastructure, like my friend is having system and I am having system. Okay, but there is a slight difference here. Need not be a particular application, specific application, but my system is available during night time. Anyone who wants to use this system for any purpose, you use it. Okay, I'll provide this system as a service to you. You use it, and after completing your use, you return back the system to me so that I can use it. Okay, so slowly the strategy changed, and the strategy is now we have a lot of resources, the compute, the storage, the network, bandwidth, several things, and all these things started emerged as like, you know, they emerged as if like they are open for everyone. They can use these service, these resources as a service, and they can return back them to the concerned person. They can again continue to use it for some other purpose. So that means multiple people can use the same system at different time slots or maybe different approaches. They can use the same system for different purposes and at different timings. So this is a great advantage of service orientation, where it doesn't restrict you for a particular application and doesn't restrict you for a particular time, but it actually gives you a flexibility to provide every resource available as a service. So imagine it's not just my one single system, but my single system is expanded in such a way that it's spanned to a room, number of systems in a room, and number of systems in a house. Again, I expanded it and it expanded to number of systems in a house. And I further expanded it and I made it across the city, like entire Warangal city, entire Roorkee city. Okay. And number of systems increase. Like I'm keeping on increasing these systems, and I'm providing them as a service to the people. But having a single system, access is easy. But as the number of systems increase, then how to provide all these systems as a service to the people? a city level of computing system. How do I make them as if like they are a single system? So this strategy we call it a single system image. So you have to create these millions of computing systems as one single system. And there we talk of middleware and other components. And one sort of such a approach is your cloud, which allows you to use the resources on service basis. These resources, which are like span across the globe, need not be just one place, but span across the globe. And what is the advantage of this? This improves the simplicity of doing your business, and most importantly, now earlier you used to have the systems, you used to have the servers, you used to have the storage, you buy it, you establish it, and if it gets outdated, you throw it. Like you have to do a lot of maintenance to that, and this maintenance can be minimized substantially. Let me repeat, substantially. How much? Approximately 70% of the budget can be saved if you transfer this burden. So one side burden, time, and at the same time the financial aspects. So all these can be delegated to somebody else who takes care of this business, and I do my business. So if I'm a teacher, I'm an educator, then I focus on education. I focus on education and let other people who are experts in IT business will take care of this maintenance and doing the other things. Okay. So this way, I reduce my investment by at least 70% of that. So that's a great advantage of cloud computing, which minimizes your investments. And how this is possible, how this can be realized, one of the fundamental backend support for your cloud computing is the virtualization. And in any computing system, actually, when you see here, you can virtualize at different layers. Okay, these are all the layers you see here. These are all the layers. I think my pen is creating some problem. Okay. So these are all layers, what I'm trying to say. So this is the library functions layer, this is system calls layer, and these are the privileged instructions layer. So what you can do is you can virtualize at every layer, so that the advantage of virtualization is that these resources, suppose if you are talking about hardware resources, if you are talking about operating system resources, or some libraries, or any application as a matter of fact. Okay, so all these can be used by multiple people at the same time with different purposes. So this is the great advantage of virtualization, and the machine which is working on virtual appliances is the virtual machine. So you have the physical resources here, okay, and these are the software resources, and software resources and physical resources both can be virtualized in such a way that they can be used by multiple people. And there are different types of virtualization that exist. You can do the virtualization at the assembly level, system calls level, API calls level, and every concerns. Give me a minute, please. Okay, so moving forward. Moving forward, so there are you can have multiple types of virtualization. There is a virtualization layer you can install on the operating system, what you have on your actual hardware. Then with this virtualization layer, you can establish multiple guest operating systems and all these guest operating systems work as if like they themselves are the machines. So these machines, you refer it as virtual machines. Okay. So the virtualization helps to create virtually multiple machines on a single machine. They appear as if like they are the independent machines. And this type of virtualization, where there is a virtualization layer installed over the host operating system, is called type 2 virtualization. And contrary to that, without any operating system, host operating system, you have hypervisor software, which itself acts like your host operating system and allows you to virtually categorically, separate the resources for different machines. So these are also different types of virtual machines. So you can create virtual machines in different forms. Okay. Or else you can also create a kind of para virtualization where it's a combination of both, which might have a virtual machine monitor, or sometimes the particular VM can like what do you call bypass this virtual monitor, can directly take the resources of hardware through your host operating system. So these are the very important three things which actually act like backbone for your cloud computing. Why? Because we have the same set of resources, but these set of resources are now more efficiently used by different people at the same time. That's a great advantage. I'll give you a very interesting example here to make it meaningful. That if you take a computing any processor in your computing system, the processor, what do you call, like it takes but the utilization of this particular CPU or the processor is only 15%, because most of the time the CPU has to sit idle. 85% of the time the CPU has to sit idle just because it has to go for memory access, it has to go for IO or any other purposes. And during this time, CPU has to sit idle. So what it should do during that time? So can anyone take the advantage of this, that it is anyhow sitting idle for like 85% of the time? Let a new machine created and that new machine takes this remaining 85% as an advantage. Let's say that also uses 15%. Still you have like 70% remain. So keep on like adding more number of virtual machines, then the utilization of the same machine substantially increases. That means only one machine is virtually created, the same CPU is separated virtually to help multiple machines. Okay, these are the virtual machines. So that's the essence of virtualization, which allows you to improve the utilization and all the resources in your machine in such a way that virtually multiple people can use it. Okay, or multiple applications can use it. And yet another advantage of this virtualization is that because of the same resource used by multiple purposes, so you can see that the physical servers earlier we used to have are like, if I have to use 1,000 servers, now this particular approach requires only 80 servers.
Excuse me, sir.
Yeah.
Sorry for disturbing, but your PPT is not visible, sir. Some of them are putting in the chat box that PPT is not visible. They can see only you.
So how is that possible?
Stop sharing and share once again, sir. Maybe
Yeah, maybe
I'll do
that. I'll do that. Come on. Oh, many people say that it's visible.
It's visible, sir.
So nice.
Yeah, now the presentation started, sir. Thank you.
Okay, nice. Okay. So moving forward. So if you see these statistics here, you can see that like there is a substantial decrease in the requirements after I use the virtualization in my computing systems. Okay. And not only that, that all of course reduces the cost. This is the major advantage. Reduction of cost is one of the major advantage. Okay. And second important advantage is that the power requirements and cooling. Okay. So the summary is that like earlier, if I have to host a website, then I have to buy a server. I have to install my web application, web server in that. I have to install my application server. I have to install my database servers. All the tools in that. And all these tools are made active. And in a quickest manner, it takes at least 45 days to do it. But with the advantage of your virtualization and cloud computing, it takes hardly 35 minutes to, like, you can deploy a server. That's a great advantage. And cost reduced, time reduced, utilization substantially increased. So this is a great advantage of your cloud computing. So that's a basis, like, why cloud computing is important. So now let us understand what is actually a cloud computing is. So cloud computing essentially is a shared pool of configurable computing resources, like your networks, servers, storage, applications, and services. Everything is covered as, these are all now the resources. So in our computing terminology, now these are the resources. Or in your cloud computing terminology, these are the resources. So these resources are shared by multiple people, and they kept it in a pool, so people can take from that pool, use that resource, and keep it back in the pool. Okay. And that's how these resources are efficiently utilized by the multiple people. So same set of resources, but multiple people are using in a efficient manner. Okay. And this is allowed, the major advantage is that ubiquitous manner. That means you can access these resources from your desktop system, server, workstation, mobile device, anything you want, iPad or notepad, whatever it is. Okay. So this is any device paradigm. Okay. And convenient anytime. On demand, like whenever you want and wherever you want. So anywhere, anytime, any device is the policy that cloud computing enables you to access the set of resources that are existing in the cloud. And these are provided as a service. You please remember, these are provided as a service to the users. Okay. And provided rapidly and released rapidly. So whenever I need, I take them, use them, and return them. It's the entire process is very quick. As I mentioned, like in a couple of minutes. Not even takes like months or days, even not hours. Okay. And another important advantage is that minimal management effort. So you don't need to worry about anything. All the server creation, everything is taken care by your cloud provider. You just plug in, use it, and return it. Such a simple, method it is. And that's what the definition of cloud is. It is actually defined by the standards institute called NIST, the National Institute of Standards and Technologies. Okay, so how this cloud actually works? What is the backend mechanism of it? So as I mentioned, virtualization is the fundamental backend of this cloud. But apart from that, it uses the service-oriented architecture in the backend, because it uses services. So you have to start the service, you have to stop the service, you have to resume the service, pause the service. Like you have to make a lot of service-related activities, right? And this you can do automatically as much as possible. So it is autonomic computing. You like as I mentioned, millions of computers are there, or servers are there, and these millions of servers, someone cannot personally go and make the changes to that, right? Or identify the faults or whatever it is. So these servers should be smart enough that they should identify the fault, they should identify the problems, they should identify the the requirements and requests, and they should automatically respond to all of them. There must be some intelligence built in inside the systems. So that is an autonomous computing environment. So that's a next important backend for your cloud computing. And ultimately, since it is a service-oriented system, so when you are using the service and you are returning back, so for some period of time, you are using that resource. Okay. So from T0 to T1, you are using that service. So from that, for this period, whenever you are using this service, you must be, your usage must be metered. Something like your electricity meter, water meter, gas meter. You have a computing meter which actually measures what are the resources you are using, for how much period you are using these resources. Okay. How much volumes of these resources you are using. What kind of things are measured, and based on that, if required, you will be charged. So that's the job taken care by your utility computing business. And you can deploy a cloud in multiple ways. Like private cloud is exclusively meant for a particular organization. That means only the employees of that organization can access the cloud resources, none else from outside. And public cloud allows every user to access the resources. Okay, suppose IIT Roorkee is having one cloud. So that's a private cloud which is exclusively meant for their employees. Okay, and anyone from outside the, someone from Vagdevi, someone from your institution cannot access these resources. If they need these resources, they have to make a request to me. I have to create some sort of instance for you, and you can use that. That means the resources are not freely available or easily accessible. There are restricted access. And public clouds are open to all. Anyone can make a request, and they get the resource provided, instance provided. And hybrid clouds are the combination of both, where suppose IIT Roorkee is having some cloud, at some point of time, they are getting exhausted with the resources. Probably they can have a tie-up with some AWS cloud or Azure cloud or Google cloud, with some other cloud partner, and they have a collaboration with them. And whenever I'm short of resources or some sort of cloud functionality is not there in my computing environment, or let's say during the peak times, my resources are getting exhausted. So in all such environments, I can take the help from the public cloud systems. But the services are actually routed through your private cloud environment. Okay. So this is hybrid cloud. And it is also possible that I'll give an example. Like if you check your mobile device, you install Facebook, you install Twitter, you install your WhatsApp, like so many social media, and as well as Gmail, email services, right? All these apps more or less are having some sort of backend in the cloud. So cloud in the backend. Okay. That means you are already working with multiple clouds in your system. Okay. So such an environment is a multi-cloud environment where you are having access to multiple clouds. Okay. And federated cloud is something like having access to public to public, public to private, private to public, like all the combinations are possible. Okay. So you are giving federation to the typical other clouds. Okay. And as I mentioned, the essence of your cloud is to provide the services, and we have already studied that there are servers, there are networks, there are bandwidth, there are storage, several resources are there, they are provided as a service. Okay. And in this particular, the cloud is getting evolving day by day in such a way that it's not only about those resources, the physical infrastructure, but the cloud started evolving to provide your software as a service, like your, for example, your email services. Let's say your, MS Word, your PowerPoint. MS Office 365 is meant for that, right? So Google Docs is another example where it provides software as a service, right? Whatever the applications you are using, all the applications can be provided as a service, so that you don't need to have these systems locally working. They work in the cloud. They give you the results at the local system. Okay, and you can also use these computing resources for developing your programs and other applications. So the cloud can be used as a platform for all the development environments. Okay, and you can store it. You can use the store the data in it. You can retrieve the data in it. And if you are already having some data, let's say some healthcare data is there, that healthcare data can be provided as a service to some pharmacies. So some hospital having all the healthcare data may provide as a service to pharmacists. The pharmacists may analyze that data, understand how the health of the people are changing day by day. Based on that, they generate the medicines and all that. So data can be provided as a service, and in fact, your security itself can be provided as a service. An antivirus software tool can be provided as a service. For example, virus tool is a very good example for that. Okay, and your desktop can be provided as a service. Like TeamViewer, most of you must be knowing, right? So it provides you the desktop to, it uses remote desktop option, but typically it is provided as a service, and in the backend in your TeamViewer, the cloud actually works. Okay, and there are many ways in which you can use it. Function as a service we will discuss in the coming time, and even data analytics can be provided as a service, where you have several virtual machines having machine learning algorithms running in the backend, and just you submit your application. The machine learning algorithms are already there, and they provide the analytics for your submitted data set. Just submit the data set, and you configure it, then automatically it produces the results and gives you the output. So analytics can be you don't need to install any analytics or machine learning algorithms or systems programming skill. Nothing is required. Just plug into your analytics module of your cloud and connect your data set to that. You get the results. So everything is becoming in such a way that you don't need to do anything. Everything is done from your cloud. So that's a great advantage of cloud, which provides everything as a service. Okay, so what is actually a cloud is basically, okay, and if you see this figure, this is one of the private cloud, as I mentioned. We have deployed in our IIT, and we are doing a lot of research in this. So you see here, these are all different servers now. Okay, so you don't need to have a physical server. These are all the virtual servers. These are all the virtual machines now. Okay, so there are multiple virtual machines in my system, and these virtual machines are actually running in the cloud, the physical infrastructure, the hardware components of my system. Okay, so they do their job. So now what I have to do is I have to select with just a mouse click, what is my purpose of using this cloud. Okay, whether you want to use it for computation purpose, okay, or storage purpose, or running your emails, applications. What is the motive of it? So just create one server virtually. So then configure this server in such a way that this server has the required software, whatever you are expecting. So then this server will act as if it is a separate physical server that is there on your desktop. So as if now here I am having a couple of near 7 to 10 servers here. So on my mouse I am maintaining now 10 servers nearly. And if you talk of Google, if you talk of Facebook, if you talk of big data centers, they handle zettabytes of data where they have millions of servers, and they do such a management there. Okay, so this is how I can create a virtual machine using in a cloud environment. I can make it used for whatever the purpose I want to use. Okay, so that's a great advantage of cloud, which allows you, which gives a lot of flexibility to install and use it. Suppose if my purpose of using this server is over, and then what I can do is just simply I can select this one and I can use option called delete. Then somewhere here I can use option called delete. Then this server is deleted. That's it. So this server is no more accessible now. So again I have to reinstantiate it, or I can choose to pause it. That means I am not making it active, but I am making it inactive for some period of time. So if it is inactive, probably less charges will be awarded, and if it is already active and more number of people are accessing, maybe more charges are offered. So that way I can change my costing or billing cycle also. So such easy a cloud management is now. Okay. So that's a basic idea of what cloud is, and there are a lot of research challenges in your cloud, issues in your cloud. Really one has to learn all of them if you want to become master in this. Okay, so as I mentioned, virtualization is the basic thing, or you can enabling technology in your cloud. And later we have seen a lot of innovations in the virtualization itself, and now we have improvements, and we are seeing recent changes like containers and Kubernetes, etc., which are improvisation of the virtualization technologies. And cloud is having several challenges like interoperability, vendor lock-in, or migration problems, where let's suppose that I have two systems. I have a cloud. Okay, I have a cloud. Okay, I have a cloud. Okay, and let's say, let me call it as a data center or whatever it is, right? So there are two data centers, and there is one system, and let's say this is virtual machine 1. Okay, and there is another virtual machine here, right? And these two are working together, let us say. Okay, and then if they are belonging to the same cloud provider, we are not having any issue. But if they are from different cloud providers, okay, let's say this is cloud provider 1 and this is cloud provider 2, then the actual problem arises. The problem is some features this cloud provider offers may not work with this cloud provider when I move this application to this provider. Okay, and some other times, so that's the problem of interoperability. That's the problem of vendor locking. Okay, where the features are locked in such a way that some features are, they can work only with a particular cloud provider. Okay, and the other is the interoperability, where there are different providers, but there must be some features that make sense in such a way that they allow you to work with both the providers. So in a multi-cloud environment, there is a need for interoperability, where you can use multiple clouds together to achieve your job. Okay, and some other times you may need to some application is running here, and I want to save the energy of this, so I want to shut down this because only one application is running on this, whereas this let's say this server is having some space to run one more application, and it's underutilized. So okay, so the point what I'm trying to say is, I can move this application onto this machine, so that this machine can be turned off. Okay. So this movement, you call it as migration. So you can migrate the application from one VM to the other VM. Okay. And this migration can be live migration or like offline migration. Yeah. Next important concern is your service level agreements. And this is the very trickiest part, and metering and billing. So there must be some mechanism to have a proper agreement between the cloud provider and the customer. And also there must be proper metering and billing cycles. So there must be algorithms designed in such a way that they do this business automatically. Okay. And next important concern is, like as I mentioned, utilization is one of the primary concern, utilization of the resources. So resource utilization is one of the primary concern in your cloud environment. And this is possible when you properly schedule the resources to different workloads. Okay. And these resources, after scheduling, must be provisioned to the users. So these three are very, very important concerns. You can say like a kind of backend support for your cloud. Without proper efficient utilization, your billing will increase. Okay. If efficient provisioning is not there, then customer will be disappointed. Okay. So that's why there must be a mechanism to balance the load and efficient scheduling approaches. And all this must happen in a fair manner and with optimization. Okay. And at every point of time, there must be ease of access for the client. At the same time, this ease should not compromise on the quality. So all the services must be provided with the quality, right? And other important concern is like what storage mechanisms you are adopting. Olden days we used to have like block storage, file storage. Later it has become block storage. Now we are talking about object storage, right? So different types of storage mechanisms are there. So which storage mechanism you are adopting? I mean, are your cloud computing systems compatible with your state-of-the-art systems? Is one of the important concerns. And what sort of file systems you are using, like is also another important concern. Okay. And later, what kind of programming models you are using is next important concern. Like whether you are using sequential programming or parallel programming. One second, please. Yeah. Yes. दो तीन points के लिए. Yeah. Okay. So sorry for that. And most important concern is like energy management. If you see any cloud computing innovations these days, they are all designed in such a way that energy saving is kept in mind. Okay. So because imagine like if you keep your laptop on your lap for 5-10 minutes, half an hour, 1 hour, 2 hours, like it starts getting heated up and your lap starts burning. Okay. Or at least you sense the heat, right? But if you have millions of systems and they're all together, imagine how much heat they are generating, how much power consumption they are making. So that's a very important concern. And how this heat is going to impact the sensitive hardware parts of the computing system, right? So that's why the very important concern is to save the energy, minimize the number of machines to run on the data center, and try to design the systems in such a way that they use some sort of internal cooling system or external cooling system to minimize the heat. And also like these cloud computing systems are typically designed in such a way that the general purpose applications are one side, high performance computing applications are the other side. So high performance computing systems actually focus on computing as a main purpose, as I told you, scientific applications and all that. But these days, like most of the cloud systems are designed for data intensive applications, because data is growing abnormally, and you need to have some kind of approaches which quickly process this data and produce the results. So your cloud computing systems are evolving in two aspects: data intensive cloud computing systems and compute intensive cloud computing systems. And in our lab, we are working for both the purposes. And of course, there is a lot of research going on in security, privacy, and trust. Typically, we trust the cloud environments, but as I mentioned, security is one of the major challenge compared to any other aspect what I mentioned so far in the above list. And alongside, there are new trends day by day evolving, and your cloud computing systems must meet these new challenges alongside. Like one side, artificial intelligence, IoT systems, blockchain, the way with which we think about the technologies are changing. And the other side, edge computing, fog computing, the way with which the cloud is evolving is also changing. Okay. So you must have a compatibility to all these new kind of technologies so that your cloud really makes meaningful. Okay. So that's an introduction about cloud computing. So any quick questions, one or two questions? Any quick questions? Yeah. So network virtualizations, software-defined networks. I mean, NVF and SDN are very popular these days. Yeah, they do a lot of help to us. Okay. And migration is migrating the application, whichever is running on your system on a particular virtual machine from one virtual machine to the other virtual machine. Data science itself is a kind of study. It's not an application, it's a study. Understanding different concepts related to data management. Federated clouds are used with when I'm as I told you, like IIT Roorkee is having a project cloud. Okay. And I may be needing some other resources from the let's say AWS cloud. But at some sort of time, the AWS cloud may not be having the requested resource, but already I have a tie-up with so what the AWS cloud has to do, it has to take the resources from other cloud which is having these resources. Okay. So I don't know from where I am getting, right? There is a chain of clouds federated from one to the other, and so on. And I'm getting the services, doesn't matter from where I'm getting. Yeah, community cloud is some sort of, as I told you, some community of people who are working for a particular application. Okay, a scientific application, let us say, a weather monitoring application, or atmosphere, what do you call atmosphere science people, earth science people, earthquake engineering people, right? Or civil engineering people. These are all different communities, right? They work for a particular problem, to solve a particular problem. So these people together work for a particular application, and that application is deployed in the cloud. So that's what is the community cloud. What is the most important challenge in cloud security? That's a good question. Maybe I'll give an interesting example to you to make it simple for you. You all must be using WhatsApp, right? So if I am sending a message to all of you, 100 people in this course, Okay. That just I'm sending my photo to all 100 people. Okay. Or else, let me put it this way. I can make it more better. Let's say there is a brochure of this course. This brochure of course is sent by Aisha Banu madam to all of us. Okay. And what I do is, because I received it, because I mean, let's suppose that you are all in contact with me, I'll forward that to you, and you will forward to others. So what happens in every case? The same copy is stored multiple times on your device. So is there any way that in your WhatsApp, first question is, if the image is same, or if the brochure is same, PDF file is same, document is same, why WhatsApp is making multiple copies of it? Why doesn't it know that it is the same one and make a single copy of it in your system? Okay, that's the first point. And if, let's suppose that there are multiple copies stored. Is there any way that I can minimize this number of copies? I can identify locally some way that, and I can, I mean, deduplicate it. There are duplicate copies maintained. I can deduplicate it. So in the similar way, cloud is having, WhatsApp of course is a cloud, and in the similar way, cloud is having huge amounts of data, and most of the data is duplicate data. So one of the biggest research challenges is to deduplicate this data, which is already stored in the cloud. Like most of the people upload the same video, same photographs, right? So I mean, multiple copies are stored. Instead, I can maintain only one copy, and I can just give the links to multiple people to the same data. That way, lot of storage can be saved, right? So this is one of the major challenge in your cloud. And if I do that, another big challenge is the security. Suppose if the same data I'm giving it to multiple people access, there is likely possibility that these people may be of different users, and one of them may be malicious, right? So that they may attack on your system. And another major weakness is that there are virtual machines. So these virtual machines are actually come on. So these virtual machines are actually shared by same set of resources, right? My goodness, pen is not working properly. Sorry. Okay, let's say these are actual hardware resources, and there are, let's say, two virtual machines here. Okay, so let's say this is memory. Okay, and this is VM1 and this is VM2. But here, VM1 and VM2, both of them are sharing the same memory. What are the chances that through this common memory, this VM1 may attack on VM2? What we call that cross VM attack. Okay. So cross VM attacks are very common in your cloud computing. Denial of service attacks are also very common. Like if you deny access to a cloud, entire cloud, then lakhs of people, they go, they get disconnected from your cloud accesses. So that's how, security is very, very crucial in your cloud. Yeah, as I said, private cloud is typically meant for my organization. Community cloud can be meant for public also, but that public exclusively working on a specific problem or application. Yeah, multi-cloud is independent cloud, like Google Cloud, Amazon Cloud. I'm taking different, I have installed my Dropbox, I have installed Google Drive, I have installed OneDrive, let's say, different storage services. So I'm using them different, independently. So multi-cloud is the independent uses of multiple clouds. Okay. Whereas federated cloud is like one cloud is taking the services from the other clouds. Okay. I think that's the end of all the questions. Okay. Okay. So, madam, should I need to close the session, or should I continue for 5 or 10 minutes?
Sir, already everybody has joined the central inaugural, sir. So
Okay.
I shared the link here also. I request you all to please also join in this YouTube link, sir, which is there in the chat box.
Okay. Okay.
And sir, thank you so much, and sincere apology from my side because you have prepared a lot of stuff to share with our participants, but due to this sudden program of central inaugural, we couldn't give you half an hour time at least, which we promised you.
No issues. No issues. No
Sincere
issues.
apologies, and thank you for the wide knowledge that you have shared to all.
I'm happy that I was joining the session, and thank you for giving me the opportunity. Yeah, you're right. I wanted to discuss some of very important topics like edge computing. These are all future for the people who are doing research in the cloud computing, and serverless computing is also another important topic.
So can you
One has
share
to
learn. If you have no problem, try to share the slides to me, sir. I'll pass it to the participants along with your mail ID. If anybody is interested, they will be in touch with you.
Okay.
Thank you so much, sir. Thank you. I request all the participants to please join the central inaugural. The link is being given in the chat box here. And after the central inaugural, we will meet at 12 o'clock for our next session. And then I'll give you the attendance link also. Thank you so much. Satish sir, kindly, if you are free, please join the YouTube link also, sir, for the central inaugural.